BCD School started indeed 10 years ago in 2015. It was a great adventure and we didn't expect it to be such a successful and long story. People who met there were very active and creative and were able to maintain this program for such a long time. And now we come here 10 years later in this wonderful place with excellent support from the European community by this Erasmus Mundus program that we were able to build up, starting from this common adventure between the three universities. This year we are very happy to see back, to start with Joachim Brod, who was in a tenure track position in Dortmund and came as a professor in 2018.
Yes, I've been here in 2016, 17 and 18 when I was actually a junior professor in Dortmund, and I'm now in Cincinnati, but I was invited as a guest lecturer.
We are very happy to welcome him back to set the ground on which particle physics is based on the theory side, which is the standard model, which he introduced in the first lecture of the week on Monday morning.
So I talked about the standard model of particle physics, which basically summarizes all we know about the particles and their fundamental forces in the universe. So there's some symmetries and focus on the symmetries of the standard model. So some of them are related to the forces and how particles interact with each other. And there are other symmetries that restrict how particles can decay or cannot decay. So that's what I explained to the students. School changed a little bit since then. Back then there were mainly students from Bologna, Clermont and Dortmund. Now it's very international and it's very interesting to meet students from all over the world essentially.
We have a traditional session of student presentation, which is always very important to have the people coming here to present themselves on the scientific level. What are the topics they liked or worked on or particularly excited to study and dig further in the future.
My name is Anastasiia and I come from Russia. Specifically, I come from Siberia, which is very far away from Europe. The research that I did throughout the years had mostly to do with neutrino astronomy. My main area of research for the last years was the multi-messenger astronomy and the visualization of the data from multi-messenger astronomy at the Baikal GVD. My presentation today was about the Baikal GVD Neutrino Telescope, and this is the telescope where I did my undergrad research, and it's a fascinating, rapidly developing project that has to do with neutrino astronomy, and I gave the overview of the telescope itself.
Koen Denekamp. I am from the Netherlands. I did my undergraduate program at the Liberal Arts and Science College in the Netherlands, which means that I have a bit less of physics background, but I have more background in other parts, such as econometrics and even archaeology I dabbled in. So I did my presentation as my bachelor thesis, where I looked at multiple different machine learning models to reduce a type of background in real analysis. We found that the established method worked the best. We also looked at different parts of the process to see what we could do to enhance the model before even putting stuff inside the model.
My name is Ephrem, Alemu, and I am from Ethiopia. My presentation is part of geophysics, and that studies about the integrated geophysical method for the real world problem like the groundwater aquifers, existence, and quality, how we mention whether the existing water is qualified for drinking or not based on the data we have from the resistivity and the magnetic methods. I did this during my previous master's degree in Addis Ababa University, Ethiopia, 2 years ago, and I did all the starting from the data collection and all the stuff in Ethiopia, Addis Ababa University of Ethiopia.
I love the school of Cargèse. It's fascinating scenery.
The view of the place also gives more sense.
Both relaxed, but also you learn a lot during the day, and in the evening you can relax with your friends.
And I do definitely enjoy the lectures that were given throughout these days.
Yeah, more than I expect.
Wonderful.
Thank you.
Who came first last year. He will talk on the granularification ideas. The projection in the theory sense for the extensions of the standard model. He will also talk about the aspects of flavor physics from this beyond the standard model perspective. We are very happy to have the people from Bologna, Professor Carbone, who was a historical co-founder of this series of schools. Maxioli was also an original co-founder of the school. We will have a sort of guest lecture on effects of quantum correlation in high energy physics, which is a topic that emerged recently in analysis at the LHC. And it's very interesting to see that this thing, which is all over the journals of popular science, more in atomic physics and quantum computing, also has manifestations which are important in high energy physics. Together with Fabio Ferrari, also from Bologna, who actually was a student in the first edition in 2015 and is now coming back.
Of course, I was a student 10 years ago, and I would have never imagined that I could have come from on the other side of the desk to teach students, and it's always nice to come to this very beautiful place. It was a lecture on CP evaluation in charm on the experimental side. I think that it was a good sequel of the lecture that Professor Carbone did, because he covered the theoretical part, and I tried to highlight the most recent results in CP evaluation in charm, especially from the LCB experiment. That is the experiment where I work in.
I'm Veronica Mungai, and I'm from Bologna, so Italy. So I was talking about the optimization of a traffic light network, which means basically trying to increase the flux considering the average density of a network. And trying to increase average travel times in the entire network by coding my own algorithm and comparing to a previously coded algorithm by some of my fellow colleagues.
So my name is Hamza Al-Haddad. I come from Yemen. I did a presentation about something called the innermost stable circular orbit, which is a concept in general relativity about the closest possible orbit a particle, a test particle can have around a black hole or a neutron star. The school here in Cargèse is awesome. It's a lovely scene. We have a sea next to us.
The sea, the mountains, whatever, like amazing. And the class with lectures, also very nice, because they start from something we know and then they just go to other topics, and we're just there. And I'm actually pretty interested because that might be like research topics I will be researching in a few years.
It's like a vacation, and we do physics in it, so pretty good.
Samuel Stamu, who is not in his first coming to Cargèse BCD School. He has been presenting very lively, deep theoretical aspects of axions and the strong CP problem of the standard model. People very much liked. He has been awarded the best lecturer prize in the past already, and so we'll see how well he can do this year. I'm sure it will be perfect. Then in the afternoon on Thursday, Chris Delic, who is in Dortmund but mostly based at CERN, where she was in charge of the jet physics in the Atlas collaboration. And she will present precisely these aspects of strong interactions and jet analysis that are very crucial to the analysis of physics at the LHC. Then we're very happy also to have Valentina De Romeri. At the time we started the school, was actually a postdoctoral fellow in Clermont with the European program Invisibles, of which she has been a very active member ever since.
It is my first time here in Cargèse. I'm very happy to be here because it's a beautiful place and also a beautiful opportunity to stay with the students and exchange ideas and discuss with them. My lecture was about neutrino and dark matter physics. I gave a basic introduction first to neutrinos, some overview of their history, how they were discovered, and then I also discussed a bit the phenomenon of oscillation. And I will also review the current understanding that we have of neutrinos and some open questions that are important for this topic in physics. Regarding dark matter, instead, I also presented some evidence that we have for the existence of this invisible component of the universe. And we'll also discuss some possible candidates for dark matter and, let's say, how we search for them.
I'm Ekta Thakur and I come from Nepal. So I discussed my bachelor's thesis. So this was in experimental high energy physics. I studied the kinematic distributions like transverse momentum and angular distributions between the finite state objects of two standard model processes at different collision energies. And these were 5 different collision energies to be exact. So 2 TeV, 13, 66, I'm missing something, 33 and 100 TeV. So I go from 2 TeV to 100 TeV and look at what the kinematics of standard model processes look like. And I studied these for Drell-Yan and TT-bar production. This analysis is going to be useful because various high energy colliders have been proposed to be built in the future. We know about FCC, for which will work at 100 TeV. So these kinds of studies are going to be useful for future analysis.
My name is Mohammad Hassan and I'm from Pakistan. My presentation was about a paper by Professor Stephen Gubser in Princeton, and it was about calculating the drag force on a quark as it passes through a quark-gluon plasma, but using string theory and using the ADS-CFT correspondence, which is that if you have gravity theory in a higher dimension, it corresponds to a quantum field theory, which we're trying to study, which is what the QGP is in a lower dimension. I'd give a particular example where we took a 5-dimensional black hole and a 5-dimensional string theory, and it corresponded to the 4 dimensions which we have in a cork gluon plasma. And I calculated the relaxation time for the cork and the drag force.
I love the school here because, I mean, we're on an island, we get to see the sea every day. I come from a landlocked country, I do not get to see the sea.
It's a very nice break from everything that we had. There was a lot of pressure in UCA. We had to study a lot, lots of exams, and then here we're just calm.
We've had professors from Germany, US, and Italy. The kind of mixing and everything, it's a really nice vibe here.
We're just enjoying ourselves, playing together, and just living together as a class. It's just lots of fun.
And then the IMAPP song?
Oh, I don't think it's gonna happen. I'm sorry. Because just nobody is that serious to make the song. I would be willing to, I would love to. Maybe you could join me.
I know.
On Friday, lecture of Stéphane Monteil on the faith we have in the Standard Model and its fate under the assault of present and future experimental efforts to test what's the nature of the ultimate theory we can know about particle physics and the world around us. This is usually a very dense and enticing lecture, which he will have ample time to develop on Friday morning. To close the week, Bruna Pascual, who is a postdoctoral researcher at Clermont University, she will present us with the great tools that machine learning, and so it's a part of artificial intelligence that can be harnessed to attack the search for physics beyond the standard model precisely within high energy accelerators and detectors data. With this very dense program, I think the students will have a perfect opportunity to wrap up at the same time what they learned in their first semester in Clermont and what they will start to study in Dortmund for their second semester.
Yeah, I really love the school in Cargèse because we had series of lectures on particle physics. We also just play the volleyball game and we're having fun playing football, so it's actually a very fun place to be.
Learning about what you like with these wonderful views, with wonderful weather, little breaks for playing beach volleyball, and it's just fantastic.
And I like the environment we have, we study, we take a lecture in the room and then just go out and have a look at the beach, and it's very beautiful.
So this kind of break is good to sediment the knowledge they received in one semester for using it in the next. I think it's a very healthy and exciting break to have for the students in the IMAPP program.